Good morning, children. We proceed on doing problems in integration using the properties of definite integrals. So what we are going to do today are most important and 5 marks, and mostly we use these two ideas. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Supposing the limits are from a to b, wherever x comes, replace a plus b minus x in the function. So this question, I have 0 to pi by 2. So what does the property say? Wherever x comes, put a minus x. So let me write the property. 0 to a f of x dx is equal to 0 to a f of a minus x dx. So we are going to apply the property. Wherever x comes, let me put pi by 2 minus x. Call this is number 1. I equals integral, there is no change, sine power 7, in the place of x I put pi by 2 minus x. Denominator sine power 7, in the place of x pi by 2 minus x. Cos power 7, in the place of x pi by 2 minus x. And remember, in trigonometry, whenever I have pi by 2 minus x, it changes. Sine becomes cos, cos becomes sine. Tan becomes cot, cot becomes tan. So the transformation takes place whenever it is pi by 2 minus theta. So sine power 7 will now become cos power 7x. Instead of this pi by 2 minus x, I put only x. Sine will become cos. Same way, the denominator sine power 7 will become cos power 7x. Cos power 7 will now become sine power 7x. Call this as number 2. Let me add 1 and 2. The LHS is I. Here also it is I. Integral 0 to pi by 2 sine power 7x by sine power 7x plus cos power 7x dx. Integral 0 to pi by 2 cos power 7x by cos power 7x plus sine power 7x dx. I plus I is 2i. Integral is common. So let me write one time. The denominator is same. It is sine power 7x plus cos power 7x. Add the numerators. Here it is sine power 7x and here it is cos power 7x dx. I can cancel. So I am left with integral 0 to pi by 2 dx. Integral and differential gets cancelled. So integral dx is nothing but x between the limits 0 to pi by 2. Wherever x comes, put upper limit minus lower limit, and that is only pi by 2. If 2i is pi by 2, I will be pi by 2 2s are 4, and that is the answer. Let me say the steps once again. I equals the given function. These questions are most of the time repeated in the question papers because it's quite important to use the property of definite integral, the property of trigonometry, and the integration idea also. Well, so wherever x comes, we are going to put pi by 2 minus x. The next step, as I substitute, I doesn't change. Integral limits no change. Dx there is no change. Put only these things in the place of x, pi by 2 minus x. The very next step, sine becomes cos, cos becomes sine. And the very next step, add these two. As I am adding, integral, the denominator there is no change. So integral denominator dx I write as it is. Add the numerators because the LCM is same. Sin power 7 plus cos power 7 means up and down, numerator and denominator. I have the same old terms which I can cancel. So I am just left with integral 0 to pi by 2 dx. Integral and differential cancels. I am left with x between the limit 0 to pi by 2. Put upper limit minus lower limit. 2i is pi by 2 means I equals pi by 4. Question number 5. I equals integral 0 to 1 log 1 by x minus 1 dx. Here again we use the same old property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Let me simplify the given question. 0 to 1 log, the LCM is x, it becomes 1 minus x. Call this as number 1. Now wherever x is coming, I am going to put upper limit 1. So 1 minus x. I equals integral 0 to 1 log of 1 minus, wherever x is coming, 1 minus x. Wherever x is coming, 1 minus x. Simplifying this answer, I equals integral 0 to 1 log of 1 and 1 will get cancelled. Minus of minus x is x by 1 minus x. Call this as number 2. As before, let us add 1 and 2. Here also I, here also I. So I will write I plus I integral 0 to 1 log 1 minus x by x dx plus integral 0 to 1 log x by 1 minus x dx. I plus I is 2i. Integral the same. Log in addition. Whenever we are adding logarithm, it means we multiply. In logarithm, addition becomes multiplication. So everything gets cancelled. I am left with log 1 dx. Log 1 is 0. So 0 into, when I integrate, that is still 0. So 2i 0 means I is also 0. And that is the answer. This is again an important problem wherein we apply integral property, logarithm property and also the ordinary integration. So first, the given problem we rewrite it taking LCM. Call it as number 1. Second, wherever x is coming, I put upper limit 1 minus x. When I replace, I get the reciprocal of this. The next step, we add 1 and 2. While adding, in logarithm, addition means multiplication. And usually they get cancelled. I am left with log 1. Log 1 becomes 0. Integral of 0 is still 0. 2i 0 implies I is equal to 0. Example 2.79. We are going to use this property where integral a to b f of x dx can be written as integral a to b f of a plus b minus x dx. In this question, a is 2 and b is 5. So call the given question as I. So whatever is the given question, let me call it as I and mark it as number 1. What is the property that we are going to use? Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. In this question, a is 2, b is 5. So wherever x comes, 2 plus 5 minus x, that is 7 minus x. So wherever x comes, I am going to substitute 7 minus x. So I is equal to integral 2 to 5, there is no change. x becomes 7 minus x. Denominator again x becomes 7 minus x. Root of 7 minus x dx. Simplify the answer. It is again 2 to 5. The integral of root 7 minus x by root 7 minus x. 7 and 7 cancels. Minus into minus is plus. Call this as number 2. As usual, let us add 1 and 2. Here it is I. Here also it is I. Integral 2 to 5. Root x by root x plus root 7 minus x plus integral 2 to 5 root 7 minus x by root 7 minus x plus root x dx. I plus I is 2i. Integral there is no change. Denominator is the same. And let me add the numerators. Here it is root x and here it is root 7 minus x. The whole thing dx is common. 2i is equal to, here it is getting cancelled. I am left with 2 to 5 dx. Again integral and differential will get cancel. I am left with x between the limits 2 to 5. 2i equals upper limit minus lower limit, that is 3. So I equals 3 divided by 2, and that is the answer. Question number 7, exercise 2.9. Again it is from 0 to 1, somewhat like integral 0 to a f of x dx equals integral 0 to a f of a minus x dx. So wherever a is coming in this problem, it is 1. So a minus x means it is 1 minus x. So let me put it in the equation 1. I equals integral 0 to 1. Wherever x is coming, 1 minus x. Denominator 1 minus x. The whole power 3 by 4 dx. Simplifying this, 0 to 1. 1 minus x by 1 and 1 cancels. Minus into minus is plus. X power 3 by 4 dx. Usually we add 1 and 2 to simplify the answer. But in this problem, addition will not help me. The second equation itself is simple, which I shall use to proceed. So I equals integral 0 to 1 will split it. Numerator first term by denominator minus second term by denominator. So it is 1 by x power 3 by 4 minus x by x power 3 by 4. Simplifying further, 0 to 1. Denominator power, if I take it to the numerator, it is minus. Numerator, no power means it is 1. So 1 minus 3 by 4. Again simplify this, 0 to 1. X power minus 3 by 4, x power 4 minus 3, 1 by 4 dx. Now we shall integrate. X power minus 3 by 4 means x power minus 3 by 4 plus 1 by minus 3 by 4 plus 1. What formula am I using? X power n dx is x power n plus 1 by n plus 1. Similarly, x power 1 by 4 will be 1 by 4 plus 1 by 1 by 4 plus 1. The limits are from 0 to 1. As I simplify, I equals x power minus 3 plus 4 by 4, that is 1 by 4. Denominator also the same. Minus 4 plus 1, 5 by 4. Denominator also 5 by 4. Between the limits 0 to 1. Now I can reciprocate, that is 4. Wherever x comes, I put 1. 1 power anything is 1 only. I can reciprocate, that is 4 by 5. Wherever x comes, I put 1 means it is 1 only. The lower limit is 0. So it gives only 0. So simplifying the answer, LCM is 5. Cross multiply 20 minus 4. Or I will write 16 by 5, and that is the answer. So in most of the problems, we add 1 and 2 to simplify, where the denominator and numerator gets cancelled. But in this problem, if I add 1 and 2, it will not help me in any way. Second equation alone is enough. So second equation will split the terms. First term by denominator minus second term by denominator. Can you do this here? No. Because here there are two terms and here there is one term. And that is the reason we use the property and bring about this format. Now it is simple. We have two terms which I can integrate, and I can put upper limit minus lower limit. So check which property suits which problem and apply intelligently. Thank you.